Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is for Algebra, Lesson 5-7, Describing Number Patterns. We are going to use inductive reasoning in continuing number patterns and write rules for arithmetic sequences. So, we do have a few key concepts and some definitions that we want to go over. First of all, we have an arithmetic sequence. We have a formula for it, so to speak. A of n is equal to A plus the quantity n minus 1 times D. Okay, right now that makes no sense. I get that. Let's just start labeling the pieces here. N is the term number, like the first, second, third, fourth, and so on. Term number 1, term number 2, etc. Make it a little bit bigger for you. Okay. A to the n is the nth term. So like if you want the 15th term, you would do a to the 15th. So a, little a, lowercase a, is the first term in the sequence. And D is what we call the common difference. Okay, an arithmetic sequence is a sequence in which formed by adding a fixed number to a previous term to get the one following it, and so on. So we will discuss and look at that in a little more detail, but this is the general formula for finding one. Okay, so first of all, a few definitions here. A sequence is simply a number pattern. A term of a sequence is one of the numbers in the sequence. Nothing surprising there. Oops, except you can't see that. Let me make it a little bit smaller. Okay, so it's one of the terms in the sequence, or one of the numbers. Okay, an arithmetic sequence is, as I was saying, a sequence formed by adding a fixed number the common difference to each previous term. Okay. A common difference is simply the difference between, and I'm going to abbreviate here because I don't have a lot of room, so between consecutive terms in an arithmetic sequence. And I'm just going to do A period S period. If you want to scribble in arithmetic sequence here, you can. Just didn't leave us a lot of room that time. Inductive reasoning is making conclusions based on observed patterns. So again, making conclusions based on observed patterns, which is how we complete a sequence, or a way to complete a sequence. A conjecture is a conclusion reached by inductive reasoning. Okay, so basically what we're going to be working on in this section is, again, using inductive reasonings to continue patterns and extend them, so let's look at this. Number 1 says, use inductive reasoning to describe the pattern, then find the next two numbers in the pattern. Okay, so if you're going from 1 to 3, you could add 2, or you could multiply by 3. So 1 plus 2 is 3, 3 plus 2 is not 9. So 1 times 3 is 3, 3 times 3 is 9. Okay? So the pattern is to multiply by 3. The pattern is to multiply the previous term by 3. To find the next two numbers, you multiply each term by 3. Okay, so 9 times 3 is 27, and 27 times 3 is 81. So the next two numbers in this pattern would be 27 and 81. Okay. In our next pattern, we have 1, 9, 25, 49. The pattern is squares of consecutive odd integers. To find the next two numbers, square the next two consecutive odd integers. So that would be 9 squared, which is 81, and 11 squared, which is 121. So 81 and 121 would be the next two terms in this particular sequence. Now, neither of these is an arithmetic sequence because we used multiplication here and we used powers here. So those are not defined as arithmetic sequences. Okay, let's look at number 2. Find the common difference. The common difference of each arithmetic sequence, excuse me. Okay, so what we want to look here is what number would we add to the previous term to get the subsequent one or the one that's following it? So 5 plus negative 3 would give me 2. 2 plus negative 3 gives me negative 1. And negative 1 plus negative 3 gives me negative 4. So the common difference is negative 4. So again, remember, for common difference, the definition is the difference between consecutive terms. What you want to think about, though, is what are you adding to each term to get the one that follows it. Okay? When I look here, my common difference is 3 because 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 3 is 17. So here the common difference is 3. So again, the question to ask yourself is, what do I add to get the next term? Okay, so that's just kind of a thought you might want to jot up at the top of the paper there. Okay? All right, so it's that simple, really, on that one. Now, finding terms of a sequence. Find the first, fifth, and 10th terms of the sequence that has the rule a of n equals 15 plus the quantity n minus 1 times 5. Okay, so basically what I'm going to do is use this information here. A of 1 is equal to 15 plus 1 minus 1 times 5, or 15 plus 0 times 5, which is 15. The fifth term, a of 5, is equal to 15 plus the quantity 5 minus 1 times 5. So that's 15 plus 4 times 5, which is 20. So 15 plus 20 is 35. The 10th term, a of 10, is 15 plus the quantity 10 minus 1 times 5, or 15 plus the quantity 9 times 5. 15 plus 45. Oh, I just had a brain freeze, so I'm going to check it here. 5 and 5 is 10, 60. Okay. All right. So in this case, again, once you have your rule, you can go ahead and just substitute in. Now remember that the number in the position of n is going to be the first term in the sequence. So if we were looking at this term, the first term is going to be 15. You do need to know that because you do have to have a starting point. And then from there you just apply your rules. Okay, now go ahead and please complete the quick checks so that next time we come together we can go over them and answer any questions that you might have. Look forward to seeing you soon now. Bye.